your friend and Web3 guide Hari, and today I am back with a whole new video episode of Blockchain Fundamentals. Today I will be focusing more on blockchain architecture, different types of blockchain, and how blockchain decides on whether to include a particular transaction in a block or not. That is called consensus. And then I will be doing a deeper dive into public blockchains like EVM and non-EVM chains, and I will be also explaining you the difference between proof of work and proof of stake, and I will be also doing a demo today. So hold up tight, let's get started. So hello everyone, this is the same screen where we left off. This screen represents a typical blockchain where each block will have a set of transactions and a specific nonce, and each block will be connected with the previous block through a previous tag, and the genesis block will have a empty previous tag. So here I am more interested in the nonce part. Nonce is like a unique number that is used to uniquely identify a particular block, and no two blocks will have a same nonce in the blockchain. So as we discussed earlier about hashing, we use hashing to actually find out whether there is a data manipulation happened or not by using a Merkle tree. Let me start with the Merkle tree part. Merkle tree is like a tree structure where each tree will be where each non-leaf node will be representing a hash of the leaf node, and whenever there is a manipulation of data, then we can easily then the hash will change a lot, since in the previous lecture we have talked about hashing. If there is a small data change, this will be changed, this hash will be changed, and also the root hash. Root hash is like a the hash of these three values. So if this will change, the root hash will be changed like a lot, and we can easily identify whether there is a manipulation of data, whether this blockchain is in correct state or not. I have also written some notes for you guys. So Merkle tree, as I have mentioned, it's a hash tree. It is actually used for easy searching of a block. It is used by explorers like Ethereum Explorer or any other blockchain explorer to easily identify a particular block and to search it within log n time, which is a very less time. If you want to know where the data changes occurred, then we can check if the data is consistent with the root hash. Will root have to traverse the whole structure? We don't need to traverse the whole structure to find the small part of the structure. Root hash is used for fingerprint of the entire data. Since this hash is the combination of all the hashes, we can easily use it as a fingerprint to uniquely identify the tree. So Merkle root is the topmost part. It's the data structure of different blocks of data towards all the transaction in the block by providing a digital fingerprint of the entire transaction that I have mentioned earlier. So this structure is actually used in blockchain to just to identify and to search a block, and it is used for searching and for for checking the validation of a blockchain. Let's go to the next topic, that is types of blockchain. We have broadly three types, that is public blockchain, private blockchain, and a hybrid one, that hybrid blockchain. Let's talk about the public blockchain. Most of the people here must have heard about Bitcoin, Ethereum. All the chains that you have heard about is mostly public, because everyone can take part in the validation part. Validation is when the miner or the validator will add a block to the blockchain. This process is called validation, and each public blockchain will allow you to to be a validator or to access the network, provided you have some Ethereum, provided you have some fees to pay off. There are actually typically two types of consensus, that is the way blockchain decides on the state of the blockchain. And the public blockchain, we have the main disadvantage in public blockchain is the transaction per second. That is the transaction the blockchain can handle, that can like process and like confirm per second. And it is like typically around like 15 TPS for Ethereum right now, but it will go up to 250. But this is not enough for blockchain to be a part of a global economy, like to be a scalable network. It need to be around like 1.5 lakhs. That is the long-term goal of different public chains. There's a lot of decentralization, as mentioned. Anyone can take part in the decision making, and anyone can do a transaction or can validate a like block and all. Provided like in proof of stake, if you have much stake, in proof of work, if you have done some work to like to add the like block to the blockchain. In proof of work, you need to like prove your work. You need to like your systems, yeah, your GPU need to process a particular like complex logic to find the nonce of the block, and the first person who finds it like will be adding it to the blockchain. That I will be like discussing later in this lecture itself. So transparency, anyone can actually that is the advantage, transparency. Anyone can see a transaction, anyone can read through a transaction, and they can understand from which address a user has sent and how much like funds are sent and at which time and who is the receiver. But anyone can see your like public address, but they can like figure it out that you are a sender. Like if I send a transaction, they can figure it out that Hari is a sender, but they can see my public address. That is like a anyone can see it. That is like a public identifier in the network through which you can be identified. Like not your private details, only your wallet details. Yeah. So and immutability. As you know, like validators are like chosen by like different algorithms and all. It is very hard to change anything in the blockchain. It is once it is there forever. We can do the immutable, like we can't change the state or anything after that. While the scalability is an issue, and energy consumption is the main issue, also a main issue in the proof of work, where users need to prove their work, and like if there are 100 participants, only one will be adding the like block to the blockchain. The work of the 99 will be at waste. That is the loss of energy, loss of electricity, and like loss of money also. And the privacy concerns, like every data in the public chain is public. Like anyone can see it. Anyone can see your data. If you so, note this point. Don't keep anything private in a public chain. Now let's move on to the private chain. Private chain, here the miners are actually predefined. Miners or validators are predefined, and they are like they are set through organization, like in the Genesis block itself. They were decided like these set of addresses will be the validators, and only these validators will be able to validate a like blockchain transaction or to add a block to the blockchain and all. Okay, this is the points that I have added. It is like a only permission. It is also called permission blockchain. Private blockchain is also called permission blockchain. A trusted person is charge of running the blockchain, and it is up to that person only, like that organization only, to like to make sure there is no malicious activity or not. The main advantage of this is, since we have the validators or we have the data already, the performance and speed is very high. There will be privacy is also, like data will be transaction data are visible only to authorized participants. No other person can see it. It is mostly and the control is very high. Like it's very centralized, and not anyone can see your data. This is mainly used in institutions or in companies where like a data is like is more of a private like type. And the main issues of this like is this type of blockchain is also centralization, and we need to trust a particular organization or a person, similar to Web2. So this can be only used like inside our organization, inside institute and all. And the transparency is also less, like the validators are chosen based on a single person. Consortium blockchain is like a hybrid blockchain where it is similar to private. It has benefits of a private blockchain like efficiency, like shared. It is very fast, and privacy and security are same. But here, only like here there is a group of people, like group of validators, a group of organization that will act as a validator, and there is a governance system. So it is actually more decentralized than a private chain, but it is less decentralized than a public chain, that we can say. So advantages is efficiency, shared control, privacy and security. The main disadvantage is also like a complex governance. Like decision making can be complex due to multiple stakeholders. There are multiple stakeholders, multiple validators. So that will be an issue, and interoperability will also be an issue. So now let's go on to the main topic, main consensus mechanism. That is, consensus means like how the blockchain will like stabilize, will add a block to the blockchain. So there are actually broadly two types of consensus, that is proof of work and proof of stake. In proof of work, where we like if you heard about Bitcoin, the miners need to have a lot of computing power. They all compete with each other for adding a block to the blockchain, where each block will be added by solving a complex mathematical problem that require like lot of GPU. But the main issue of this is like it is very decentralized, like anyone can take part if you have enough provided, if you have enough GPU, and if you are able to pay for the electricity bill for this GPU power. The main issue is like if there are 100 miners, only one will be get benefited by, like the person who will be adding the block to the blockchain will get benefited in terms of fees, but all the 99% will have to like lose that energy for waste, like they don't make anything out of it. Whereas the decentralization is the benefit of proof of work. In proof of stake, they are like it here. If you want to be a validator, you need to stake some tokens. That tokens need to be native. That native tokens in the blockchain, and then you will have a particular time slot. The times are actually here. The time is converted like split into small epochs, and each epoch there will be epoch leader, and that epoch leader, once you have staked, then you like it is chosen randomly or in a particular way, and that epoch leader will only be processing that block to the blockchain, that adding the block to the blockchain. So it is more efficient, but there is a decentralization issue where like since the staking amount is very high, not everyone can do it. So there are a specific set of people that can, like having a much amount of native tokens, can take part in this type of blockchain. And then let's move on to the next topic, that is EVM and non-EVM chains. In public blockchains, there are broadly two categories, EVM and non-EVM. In EVM chains support solidity, and they run on top of Ethereum virtual machine. Like there are a lot of blockchains like Polygon, Ethereum, Base, and there are other chains that support this, where you can use solidity to write your like logic, your application. Here it is called decentralized application, DApps. Whereas in non-EVM chains like Aptos or Cardano or their Tesos, in this blockchain they don't support EVM, but they also support like a large variety of languages like Python also. So if you are a Python developer, or you know Python, or you just started, you can be a blockchain developer also in the future. So that is like a small summary of it. Now let me show you the Ethereum Explorer. Ethereum Explorer is like a place where you can search for a transaction, where you can see the network. This is the Ethereum blockchain, where you can see the transaction history, the transaction per second. That is 14.5. That is very less than what they expected to be, but it will improve in the future. That is the positive way, like we think about it. So we can see the marketplace. We can, if you see this part, is the latest transactions. If you click on one, you can actually see like which address have sent to which address and how much they have sent to. Like you can see this amount, this is $132 worth of Ethereum sent to this address. At which time you can see it, the time. As you can see, it is very latest, and by this way we can actually track a transaction. We can know like who sent to which address and at what time, but we don't know the actual identity of the person, but we only know the address, public address of the person. So you can try playing with this, but just searching Etherscan, which is a Ethereum Explorer, and you can search for address, or you can see NFTs, everything. Okay, so that is it. The video is getting long, so I hope you like this video, and please subscribe, like and share, since this will be like a motivating factor for me to make more such interesting videos in the coming future. So thank you everyone.